That's what confidence level and confidence interval does. Now, the first thing you have to do is estimate a point estimate. Write that down. A point estimate is what we've been doing pretty much with z-scores, but we're going to take it one step at a time. A lot of this is going to be rehashing of the z-scores, which we just got finished with. So, a point estimate is the value of a statistic that estimates the value of a parameter. The point estimate for this section will be p hat, which means a ratio or a proportion. P hat, P with a little caret symbol on top of it. Okay, I think it's right down there below it. P hat is equal to x over n. There's 30 students in here and 17 of them are female. Then the p hat would be 17 over 30. Don't let the p hat and don't let the point estimate get you all confused. If you look at the top, what does it say? Attain a point estimate for population what? Proportion. Mark proportion out and put fraction. Because if you remember fraction, you know that you have to put the x over the n, and the n is always the what? Biggest number. It's the total. Okay? So you need to write p hat is equal to x over n. Something else you need to know. If p hat is equal to x over n, what is q hat? Q hat is the complement. What is that? The complement. So write that down. P hat is equal to x over n. Q hat is equal to the complement of x over n. So if x over n comes out to be 35%, what's Q hat? 65%. Or a while ago I said there were 17 females in here. 17 out of 30 are female. How many are not female? How many are male? 13 out of 30. So that's the complement. So remember, Q hat is the complement of P hat. And they give you an example right here, and I'm not going to insult your intelligence, but they say that 1,020 Americans, blah, 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 490 say yes. So 490 over 1,020 is going to be your P hat, or your proportion estimate. See, I'm not going to go through that because I think everybody here understands what a fraction is. Now, write down confidence interval because that is one of the buzzwords. There's two buzzwords, confidence interval, confidence level. Now, does everybody remember, and this is, I'm going off on a rabbit path here. Does everybody remember when I told y'all a long time ago that you needed to learn how to use the standard deviation? That if the mean is equal to 50 and the standard deviation is equal to 5, then you need to learn how to write 55, 60, 65, and 45, 40, and 35. Y'all remember me telling you that you needed to go 3 to the left and 3 to the right? Well, the confidence interval is kind of like the standard deviation, except the confidence interval is going to go 1 to the right and 1 to the left. So the confidence interval, P hat's in the middle, is going to be between and your upper value, which is going to be P hat plus the margin of error, and P hat what? Minus the margin of error. So this is what we call a confidence interval. So you need to write that down because you need to understand what a confidence interval is. So kind of relate it to this area right here. One standard deviation. This is kind of like one standard deviation. Okay? And erase the equals. Sorry about that. Now, the reason I'm having you write everything out in this section is because out of all the sections that we've done, this probably is the most confusing to people. And that's why I'm having you write every single thing out. Because there's 3 different ways to find the point estimate. One is proportion, one is by the mean, and one is by the mean and standard deviation. We'll get into it later. There's 3 different ways, and I want you to be able to write down every single one. Okay? And that's what they're going into right now. They're going into the confidence interval. And you can write it down. Confidence interval. There's confidence interval right here. Here's your point estimate, and then one to the left and one to the right. That's what they're saying. The confidence interval, blah, blah, blah. Confidence level. Write confidence level down. Confidence level is going to be above 90%. Why? Why wouldn't I use 80% or 70%? Because you don't want to walk into a meeting with 70% confidence level. If you walk into a meeting and say, well, I've got a 70% confidence level, they're going to look at you cross-eyed like you're fixing to get fired. Okay? You go in there with a 90% confidence level or above. Why is there not a 100% confidence level? Why do you think? Because nobody is what? Perfect. Nobody is perfect. And like you said, nobody can be 100% confident. There's always going to be something to mess up something. All right? Nothing is what? Free. Nothing is free. Nobody's perfect. And there's always one. All right? There's always one person that's going to mess it up for everybody. All right? Those are 3 life lessons. Confidence level. 1 minus alpha. We're going to get into that in just a minute. But a confidence level is how sure you are that what you've done is accurate, is valid. That's what the confidence level does. Now, what is alpha? If you want a 95% confidence level, alpha is usually the complement. So it would be 95 from 100, which is 5. So alpha would be 5. Now later on, we're going to change that to alpha over 2, which is 0.025. Okay, so you need to write down alpha is equal to the complement of the confidence level. Or you can say 1 minus the confidence level. And write down a couple of examples. Like 95% confidence level, 1 minus 0.95 is equal to 0.05. A 90% confidence level would be 1 minus 0.9, which would be 0.10. So alpha would be 0.05 and alpha would be 0.10. Alpha is the complement of the confidence level. Sorry. This is the confidence interval, and I just showed you that right here. The point estimate plus margin of error. Point estimate what? Minus the margin of error. That's where they got it right here. They're showing confidence level here. Margin of error, that's the next. It should give you they're not giving you the formula for margin of error. They're just telling you what it is. Going through that. Now, we're going to do this, but we're going to do it a little bit different. Take a part of your, let's just do it like this. Take a part of your notebook paper and make it about the size of an index card, because that's what you really need to make it. And as soon as I can get a hold of what I need to do here, let's say this is your index card. And I would probably divide it into several sections. Well, it doesn't have to be this big, but, and then maybe 10 lines this way. Make one for the top, it's very skinny, and then make 10 lines. Like so. I'm just going to do the first few for you. You might want to get your table out and your calculator. You're going to name this confidence level. You're going to put alpha here and alpha over 2 here. And we'll start with a 90% confidence level, 91% confidence level, 92% confidence level, and go all the way down to 99% confidence level. Actually, we could take it one more step. Let's see. Remember this training now. Name this alpha over 2. And then here, call this the area. Now, this will save you a whole lot of looking back and forth in your notes and in your book and all that stuff. You might want to make a card for this, or put this out of your notebook if you want, or I don't care what you do, whatever, because only 5 of y'all is going to do it. Anyway, 90 minus be 10%, 0.10. I'll put 0.9 right here so you see it. And this will be 0.05. And then you look up 0.05 in your Z table. Somebody give me an inverse norm. Let's see, it'd be 0.05. Yes. Give me an inverse norm of 0.0500. What would you get? No. Yeah. Do the inverse norm. What do you get? Negative 1.64. And they're going to want 1.64 and take the absolute value that we're getting to that later. So you need to do that with all of these. So 91%, what would be alpha? 0.09. And what would be alpha over 2? 0.045. And then do an inverse norm for 0.045. 92% be 0.08. 0.04, and so on. 95% would be what? 0.05, 0.025. And somebody give me inverse norm of 0.025. Okay, and do 99, that'd be 0.01, which would be 0.005. And somebody give me inverse norm of 0.0005 or 0.005. What would be? Okay, so you need to make your card. Go ahead and write it out since you're in the mode of doing it. Go ahead and do that. Take a couple of minutes and finish that out. I always knew there was a reason I liked Denzel Washington and Harrison Ford. They're not some of those DAs out there in Hollywood. They're both Trump supporters. Some of the people out there in Hollywood, I believe they think there's unicorns and Candy Mountains are actually real. Income equality. People in Hollywood want income equality. Where is the biggest homeless area in the United States? The biggest homeless area, where? It's called Skid Row. Where is it? Los Angeles. And how much do actors make? Actors and actresses, how much do they make? But they're all for income equality. I make $1 million, but I live in a town that has homeless people in the street. But I love income equality. Ironic. Now that, change that column over there where I've got to put area, change that to Z-score. I got it fast backwards while I was drawing it, sorry. I know y'all will never get anything fast backwards. Now, this is the funny part. In this section in chapter 10, it's going to be called the hold on, I don't forget the name of it. I don't use it. I don't use that name. It's going to be called the estimate. Where is it? population proportion, but it's called something else. Point estimate, that's what it's called. So that's the point estimate. So if you want to put above z-score, put point estimate. So if you are doing a problem and it's asking for the point estimate, it's basically asking for the z-score. Wait a minute, I shouldn't have told y'all that. That way y'all would be more confused. I'm sorry. I don't know why I do stuff like that. Go ahead and write down the sampling distribution. Go ahead and write that down. The standard deviation is equal to this. You might need to know it. I don't usually ask questions pertaining to this, but mu is equal to p. With the mean, mu is equal to p, and the standard deviation is equal to p times 1 minus p. That's pq over n, or qp over n. Because what is 1 minus p? Q. So you can write that as pq over n. And also make sure that when you're dealing with a question, make sure that n times p times q is greater than or equal to 10. If it's not, then it's not feasible. So if you're given if you say n is equal to 30 and p is equal to 0.25, then 30 times 0.75 times 0.25 needs to be over 10 or it's not feasible. Okay? So that's on page 396. And somewhere they're supposed to give us the margin of error. Not like that. That's not that in there. Okay, what is that, a blank page? Yes?
How come when the practice is explaining that after divided by 2 instead of just add?
Because we're finding that's the difference between point estimate and the z-score. It's different because we're going to be, it's taking the point estimate divided into two tails. That's why. The two tails, you know how in the previous chapter 6 or 7, you had to find the area between the two tails? Well, now you're trying to find the area outside the two tails, and that's why you divide it by 2. Because of the tails. Okay, does that help you? There's the margin of error. Write that down. See, even right here, they call it z sub alpha over 2. See there? They still call it z right here. Z sub alpha over 2. So you just have to put E is equal to Z times the square root of PQ over N. You don't have to because you got it on your card already. That's why I give you that card. And as long as you fill that card out all the way, you won't ever have to worry about looking up anything. E is equal to Z square root of PQ over N. Now that's pretty simple. And for those of you from problem estimating, usually they'll say a 95% confidence level, and right now your proportion is 0.65, and you have 40 people. N is equal to 4. That's what they'll give you. So take your information and plug in there. Do that. So you would look at the 95 on your card and go over to the last column. What's the z-score or the point estimate for 95%? Huh? So then we would go E for this. E is equal to 1.96 times P is 0.65 times 0.35 over 40. What? Now, somebody crank all that out and just give me two. Remember, what do the polls say? The polls today, for the political polls, what do they say? The margin of error is what? Come on, people. One of y'all has seen the polls at least. One. What's the margin of error on the polls that are being run right now? 2 or 3 points, Hubert. That's right, class. Y'all suck. 2 or 3 points. You don't want a poll that has 15% margin of error. Why? Because that means you went out in the parking lot, you interviewed 3 people, and you made up a poll. Okay? That means that it's not worth squat. The lower the margin of error, the better your data. Everybody with me? So 2 to 3 points is usually what you want. Anything below 2 or 3 is good. The smaller the margin of error, the better. So, somebody give me 2 decimal places because we're just wanting single digit. What do you get? 0.12. Okay. You want to set me up? Is that what you want to do? 0.15. So what kind of margin of error does this one have? 15%. How would you decrease this? More people. N, increase what? N. That's usually going to be, and that's what y'all are supposed to pick up. Most of the time, to increase a poll's validity, same thing with flipping a coin. The more you interview, the better your data is. The more you do, well, let's just say it. I know some of y'all don't want to hear this. You get out of something what you what? Put into it. You got good parents. Whoever said that. All right? It's not you get out of it what you want out of it. It's not you get out of it what you think you deserve out of it. You get out of it what you put into it. If you go to if you have a project and you go and you interview 1,000 people, then your data is probably going to be very tight. If you go out and you interview 6 people because you're lazy, then you're pretty much going to suck at your presentation. You're probably going to get fired, or you're probably going to get an F. Okay? You get out of it what you put into it. It's kind of the same thing with a job. Might want to take that with you. All right, so this needs to what? Increase. And that's what you learned with the large number rule. The more times you try it, the better. Now, that margin of error, what do you add and subtract it to? The p hat, which is 0.65. So your confidence level, see, I don't do all this stuff. Your confidence level, write this down. I'm sorry, confidence interval. Your confidence level is 95%. It's going to be p hat is between 65 to 50% and what? 80%? So we've got a 95% confidence level that our data and our calculations and our polls and everything that we've done is going to fall between 50 and 80%. That what? Sucks. Okay? You've got a 95% confidence level. It's going to be between 50 and 80%. That sucks. Remember, the lower your margin of error, the better your data is. Okay? And that's a good example. And that's how you find the confidence interval and the confidence level, sorry. Confidence interval from the confidence level. Let's see if we can find a good example to do out of the book. Well, I guess they're not going to give us a good example. I skipped the page. This is the only one. For the problem, estimate the proportion of 16/7 whose text driving determine the effects of the margin of error by increasing the confidence from 95 to 99. Well, what if you did a 99% confidence interval? Where is this coming from? Where is the 16 to 17-year-olds? Must be on previous page. This is it. Okay. Write this down. It says blah 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 blah. 800 randomly selected, randomly sampled 16 to 7 blah 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 blah. 272 indicated that they text while driving. So what is N? Okay, write that down. And X is what? Okay, so X is, now do a 95% confidence level. Give me the confidence interval for the 95% confidence level. And then do a 99% confidence level. Give me the confidence interval with a 99% confidence level. 95 and 99. Well, when you find the margin of error, you add it to the p-hat, and that's your confidence interval. So find the margin of error. All right, so to do this one, it's pretty self-explanatory, and then this part is pretty easy. And you can do it on your calculator, but I haven't had a chance to even look at it to see. I know it's under Z, but okay, if I could find the stupid no. It's the server's fault. Try-County Tech server, that's why I can't get everything pulled up. We need to indict the server. must think, they must think that the American people are dumb as a box of hammers. I mean, they must really do. To sit on national television and say, well, the server is under investigation. The server just appeared one day. It just was created. Nobody asked for it. Nobody bought it. Nobody put it in their bathroom. It just showed up in the Clintons' bathroom. Just showed up. What do you call it? Immaculate conception. And I guess Americans are supposed to fall for it. Oh, you're stupid. N is equal to 800. And T, let's see. Thank you. X is 272. So, P hat, 272 over 800. Q hat, you can either do it, subtract and put it over 800. 800 minus 272. Or you can take the complement of this. What's the 0.34, so this would be 0.66. And then plug and chug. So we know that we want a 95? So a 95% confidence level, alpha is equal to 0.05. Alpha over 2 is equal to 0.025. So z sub alpha over 2 is equal to what? 1.96. So that's going to be 1.96 times the square root of 0.34 times 0.66 over, thank you, and crank that out. What do you get? 0.03. Hey, what is that? Margin of error of 3%. Margin of error of 3. So this is a good one. This is a good one. So then we take 0.34, and that's going to be, V hat is going to be 34 plus 3 is 37, and 34.31. Now 99% confidence level. Point alpha is equal to 0.01. Alpha over 2 is equal to 0.005, which z sub alpha over 2 is equal to what? 2.57. So 2.57 times the square root of 0.34 times 0.66 divided by 800. What does that come out to be? 0.04. 4%, which P hat is going to be 0.38 and 0.30. Why would this go up? Why would that go up with this? Because the confidence level is higher. That means you're going to open up the margin of error. That's why. Okay, now I can tell by y'all's fidgeting and y'all's moving around that it must be time to go. So that's where we'll end today. So that means you can at least do some of the 9.1 homework. Okay. So for some of you overachievers, if you want to go ahead and get started on the homework, which is probably